To help determine whether God or the laws of physics alone created the universe, scientists are using multi-billion-dollar particle accelerators to take them on a journey back in time to nearly the moment of creation. To achieve this remarkable feat, physicists send subatomic particles screaming in opposite directions around enormous oval tracks. When these tiny pieces of matter reach nearly the speed of light, scientists steer them into each other. But how can these violent explosions possibly allow scientists to look back far into the past to shed light on the question of God?
What particle accelerators do is take us beyond the realm of theory and give us some direct access to the physics that prevailed at the first split second after the Big Bang.
These high-energy collisions of elementary particles that go on in these experiments create enough energy to create, for a moment, the conditions of the very early universe, and then we can actually study that moment of creation using the laws of physics.
The enormous energy that comes out of these particle collisions is a microscopic version of the superheated conditions that existed just after the Big Bang.
A useful analogy for what goes on in a particle accelerator is to actually use remote-controlled cars going around an actual racetrack. I'm actually here at a racetrack with an expert, Dana Smelter, who's been showing me how to use these remote controls to drive these cars around the track. Dana, how fast are these cars going?
They're going around 25 miles an hour, and if it was a real-sized car, it'd be going 250 miles an hour.
That's actually great for our demonstration, because having these small objects, the cars, going around the track at high speed is exactly what goes on in the particle accelerator, where you have the tiny fundamental particles being driven around the track at incredibly high speeds, almost the speed of light, being guided around the track using powerful magnets. We actually want the cars to represent these super fast particles that are going around in the particle accelerator. So now we've got these cars up to speed. I'm thinking a fun thing to do would be to actually guide them into each other and collide them. Could we do that?
We could, but you're going to get a big crash.
And what would happen?
Oh, parts are going to go everywhere.
Well, let's do it. Whoa, that's great. Pieces everywhere. Let's go and have a look. This is great.
Wow.
We have all of these great pieces.
A lot of pieces here.
The energy created in this collision immediately shatters the car into dozens of pieces. When this explosion is amplified exponentially in a particle accelerator, it creates so much energy that for a split second, the conditions around the crash site begin to resemble those near the moment our universe was created. And scientists may be able to see the hand of God starting it all.
You actually get a glimpse of what the universe was like very early on. So we get a glimpse of creation. We can actually see how things got the way they are now through physics that was going on billions of years ago. So it's as though we're going back to the factory of creation by creating a little piece of it in the experiment and allowing us to look at the creation moment and see that the laws of physics can tell us what really happened. In the same way here, we look at the output of the collision and we can use the laws of physics to figure out how the cars collided and what the cars were made of.
Particle accelerators have not yet answered the God question, because the latest technology can't generate enough energy to go all the way back to the exact moment of creation. So far, scientists have reached a fraction of a second after the Big Bang, without finding anything that can't be explained by physics.
Of course, people want to go back to the very first moment itself. That's where they might imagine that one would see, so to speak, the hand of God or the Maker's mark. We haven't got there yet.
With all the experiments and observations that we've made, we've never found any single exception to physical law. So we believe that there's a good case to be made that miracles don't happen and everything can be explained by the laws of nature.
Just because up to this point, one has not discovered anything that couldn't be explained by a physical law, doesn't mean that in the future there couldn't be literally thousands of things newly discovered that aren't explained by any physical law. Why is that? Because science itself must always be open to new discoveries.
However, if scientists are eventually able to use the laws of nature to explain everything, will we someday be able to understand, in scientific terms, concepts like the soul, consciousness, heaven, and hell?
It's probably asking too much of science to find that one day there'll be solutions of equations that represent heaven or hell or some other great thing from our mythological legends of old. It's probably going to be a lot more subtle than that.
Physicists hope to eventually have a complete scientific explanation for how the universe was created. But they say it may be beyond their grasp to determine whether or not God created these scientific laws. Unless we had a creator who left a message inside the universe's cosmic code when he programmed it.
Are there clues to the architect of that cosmic program buried deep within it, within all those ones and zeros, like the maker's mark stamped on the architecture of the universe at the outset? Well, the problem is, tantalizing though that is, one might follow those ones and zeros forever and ever and still not find this mark. I think that's a lost cause, a hopeless exercise. But in some deeper sense, the fact that the universe is mathematical, and when we explore that mathematical realm, we are, in a certain sense, glimpsing the mind of God. What we're really doing is exploring at a hidden level the order in nature.
But one of the most respected scientists in the world recently rocked the planet when he said he's explored the hidden order of nature and found mathematical proof that God doesn't need to exist.